All right, everybody. You want to go over? I went over this earlier today, but in a different way. I want to bring it back. We're going to look at again biological evolution, and they're talking about the T-Rex, what they found and what they mislabeled, and they found out they mislabeled it. They called a juvenile T-Rex a nano T-Rex, as you want to call it. So that happened in the 1980s. They began to find them, I guess, in the 1940s and 1980s, and up to this date. So it's something to look at, and let's go through it. It's exploring scientific controversies and dinosaur um, classifications. And, we give them, you know, room to make mistakes. That's not our problem. Our problem is the whole basic biological um, mindset that you can actually believe that a minnow turns into a mind and turns into a walking, talking human being. So the discovery initial identification of the T-Rex or the nano T-Rex, the lack of juvenile T-Rexes, fossils, and early interpretation. See, that's the problem. They're going on assumption versus until assumption, and they're not filling in the gap. They want to call us the god of the gaps, but they got so many gaps. It's ridiculous. Instead of seeing the biological history of the world as built on stepping stones, they want to say, no, we grew from this and we are here that and now, and this is what it is. The molecule to man theology that they have, their belief system. New discoveries, and we're going to talk about the growth series and evidence, modern perspective on the nano T-Rex, discovery and initial identification. Again, we're going to go over this, or the nano T-Rex, and the lack of still, it appears, lack of juvenile T-Rexes in the fossil um, history. The first T-Rex skull discoveries happened in 1940s and 1980s, like I said. Distinct features observed in the skull, formal naming, and the nano T-Rex in 1988. The first notable T-Rex skull was discovered in 1940, but was initially not well studied or classified. I'm sure they had other things to do, and that's just life. It wasn't a focus. They found something, and it stayed around until somebody else came around and got interested. That's how science is. Renewed interest emerged in the 1980s with further small skull findings that differed in size and proportions compared to adult T-Rex specimens. These discoveries sparked debate on whether they represented a separate species or a juvenile T-Rex individual. Contextually, the smaller skulls exhibited features not typically seen in other juvenile T-Rex, complicating straightforward identification. The small T-Rex skulls showed differences such as more slender build, a greater number of teeth, up to 17 per side compared to 12 in adult T-Rex, and a more lightly built jaw. These features were interpreted as possibly indicative of a distinct genus. However, some traits could be linked to developmental stages of T-Rex. Analyzing these cranial characteristics involve detailed comparison to understand various variations within the T-Rex. 1988, paleontologist Robert T. Baker, or Baker, is Bakker, formerly named the Nano T-Rex, based on these small skulls, proposing it as a separate genus. This naming was grounded namely on observed anatomical differences rather than extensive fossil evidence across growth stages. The proposal fueled controversy due to incomplete juvenile T-Rex records at that time and limited sample size, setting the stage for ongoing debate and further discoveries to clarify classification, which they found out he wasn't right at the time, but he made an effort. Incomplete T-Rex fossil record. Again, comparison to adult T-Rex specimens like Sue. The reasoning behind classifying small skulls as a separate genus. They didn't have enough. They went and did a wild guess and came up wrong. Prior to recent findings, the fossil record contained few well-preserved juvenile T-Rex specimens, leading to significant gaps in understanding developmental growth. This scarcity resulted from factors like preservation bias, smaller juveniles being more fragile and less likely to fossilize, and collection focus on large, more complete adult specimens. The Apache record challenged paleontologists to distinguish juvenile traits from potential species level differences in newly found smaller skulls. The adult T-Rex skeleton, Sue, one of the most complete specimens ever found, provides a key reference to size, development, and mature bone structure. Contrasting skull size and dental patterns with smaller finds show significant difference, traditionally attributed to age-related changes rather than species differences. However, some small skull traits differ enough to question whether all small T-Rex specimens belong to T-Rex juveniles. Early researchers argue that distinctive cranial features, especially the dental count and build, did not align with expectation for T-Rex juveniles. These developmental arguments, combined with a lack of clear transitional fossils, which they still lack, led to the hypothesis that Nano T-Rex was a valid, smaller T-Rex genus. This classification influenced interpretations of late Cretaceous predator diversity and ecological niches before significant juvenile growth studies emerged. Discovery of transitional specimens such as Jane and Petey patterns observed in T-Rex growth and development, bone history studies confirming rapid juvenile growth. Jane and Petey are specimens interpreted as intermediate growth stages between small juvenile T-Rex and large adult T-Rex. These finds demonstrate developmental changes through growth from skull shape to tooth count. Transitional fossils contribute strong evidence changes to this separate genus, hypothesized by filling previous gaps and illustrating a growth continuum with T-Rex individuals. This transitional fossils was within a species. This is not T-Rex to butterfly. It's not T-Rex to chicken. Detailed studies of growth patterns reveal rapid changes in skull robustness, jaw strength, and tooth replacement rate during juvenile growth, and proportionally longer arms and more teeth, which decrease as they mature. More such developmental shifts correlate strongly with changing lifestyles and different roles, explaining previously puzzling differences without requiring separate species status. Historical analysis of bone microstructure from Jane, PT, and other specimens show rapid juvenile growth with growth rings indicating a few years of accelerated development before reaching adult sizes. These findings support the concept that smaller skull specimens represent juvenile T-Rex rather than a distinct lineage, demonstrating development scaling rather than complete different species. All right, so then we'll have to jump into scientific consensus. Current consensus among paleontologists, developmental differences, and explained by the growth stage indications or implications for understanding T-Rex development. So they agree on this is a small T-Rex. Today, the majority of paleontologists lean towards nano T-Rex specimens being juvenile T-Rex individuals based on accumulated developmental, historical, and growth evidence. While some dissent remains, new discoveries and more complete growth series have largely undermined this separate genus argument. This consensus reflects advances in technology, analytical methods, and more complete fossil record. Variations such as richer tooth counts, lightly built skulls, and subtle bone ornamentations now are viewed as developmental traits exhibited by juvenile T-Rex rather than features of a new species. Developmental plasticity during growth phases is common in dinosaurs and explains earlier misclassifications of these small T-Rex fossils. Confirming nano T-Rex as juvenile T-Rex enhances knowledge about the T-Rex life history, including growth rates, ecological dynamics, and predatory behavior changes across life stages. It impacts the reconstruction of the history by adjusting population structures and predator-prey models and information broader evolutionary studies of their development. In summary, the debate over nano T-Rex reflects the evolving nature of paleontology as new fossils and growth analysis emerge. Current evidence favors interpreting the nano T-Rex specimens as juvenile T-Rex individuals, reshaping how they view T-Rex growth and development. This understanding deepens their insight into dinosaur life, history, and evolutionary biology as they believe. So thanks for that.